Yeah, not for you guys. All right, so we're going to be graphing rationals. Here in the core concept, it talks about all the stuff you need to know about how the two symmetrical parts are branches. It talks about the domain and range. So the domain and range right here, we'll go ahead and add that in. Domain and range are going to be all real numbers except for one number. So when you look left to right, we're talking about domain, left to right. This graph is all the way to the left, and then it jumps over, and then it goes all the way to the right. What does it jump over? X equals 0. So the domain is going to be all real numbers except for 0. So you can write all those words out, all real numbers except for 0, or you can write x does not equal 0. Your choice. You can either write x does not equal 0, or you can write all real numbers except for 0. And then the range, all the way to the bottom, hops over something all the way to the top. What do you think? All real numbers except 0. So y does not equal 0 is how I would say the range. Now, the vertical asymptote is x equals 0. The horizontal asymptote is y equals 0. Look at the domain and range. They are the same because the asymptote is what you jump over. So these should be the same, except for the not equal to or equal to part. Okay? So, let's try some on regular paper. Some of us don't have notes yet, but as soon as they get here, I'll give it to you. You can use that. So, that's that guy not to have it. If you don't have the notes yet, you're just going to grasp some equations. You'll get the notes so you can go look at the core concepts later. So you don't know these words. Alright. We're going to graph g of x equals 4 over x, and then we're going to talk about how that compares to 1 over x, which 1 over x is a parent function. But I'll talk to you about how it compares. Just looking at the equations, just looking at the two equations, if I have 4 over x, or I have 1 over x, by the way, this is super touchy today and keeps making extra lines and dots like crazy. Just heads up. I don't know how to fix it. Just going nuts today. If I have 4 over x or I have 1 over x, this one is how many times the value of this one. 4 times. If I take 1 over x and I multiply it by 4, then I get 4 over x. So if you're multiplying the entire function is 1 over x. If you're multiplying by a number, what kind of transformation is that? What kind of stretch? It's a vertical stretch because you're multiplying the entire function. It would be horizontal if it was only in the denominator. It's vertical, multiplying the whole function. So when they say compare, we would say vertical stretch factor of now I'm not going to do the whole table like with the transformations yet. I'm just going to do 4 over x. Because when we do 4 over x, all you have to do is plug in any x's that you want. And I think that's the only step I would need to do. I'm going to do 4 over x as my y values. So I'm going to think ahead, and this is the hardest part about this chapter is you're going to have to think ahead. Well, you don't even have to do this. But if you want nice numbers, think ahead. What number can I plug in for x will come out as a nice answer? Huh? I hear it. Did you say 3? That was the worst one. Oh, he said 8. Now, 8 would be okay. It wouldn't be maybe the best choice, but it would be okay. But how about the number 4 or negative 4? Let's start with negative. How about the negative 4? What's another number that I could plug in that would come out nice? Okay, I'll get the 4 last. I'm going to go from negative to positive. Negative 2. If I plug in negative 2, 4 divided by negative 2, that's negative 2. What's another number? Negative 1. 4 divided by negative 1 is negative 4. What's another number? Can I divide by 0? No, so I cannot use 0. How about another number? Hey, I'm going to throw one out there. Just hear me out on this one. How about negative 1/2? If I do 4 and I divide it by negative 1/2, if I divide by a fraction, that is the same thing as multiplying by its, and that is a good thing to learn because we're doing fractions this whole chapter. So instead of dividing by negative 1/2, if I multiply by its reciprocal of negative 2, I get what? Negative 8. See, that one's not bad either. Now, you don't have to do that one. I'm just showing you fractions aren't terrible. Okay, and then maybe 1/2, maybe 1, 2, and then 4. That'll give me 8, 4, 2, and then 1. Now, the asymptotes are important, so you have to include them. They are x equals 0 and y equals 0, unless we have a translation. That will move the asymptotes, so we don't have one yet. So x equals 0, y equals 0. Let's graph our asymptotes first. X equals 0, y equals 0. Now we will plot these points. These points, if you picked nice points, they will be symmetric. So there is another point that's like 8.5. Well, if you plug in 8, you can have. Like that one, if it satisfies you to have that symmetrical piece, there's a symmetrical piece over here as well. So they should be symmetrical. They should look like two branches that are getting closer and closer and closer to asymptotes. They do not pass through the asymptotes. If your points were going to pass through the asymptotes, you know you've done something wrong. It looks like I'm going to pass through here, but I'm not. If you graph what I'm about to do, which is wrong, if you graph it like this, I will take off because these get closer and closer to the asymptotes. If you're sloppy and you go like this, which I've obviously seen people do, then it's not getting closer to the asymptotes, and I would take off. It gets closer and closer and closer to the asymptotes, never passes through it. And that's it. Can you make a table for the next one? Make a table for the next one, for the next question. Oh, you don't see it. All right. Next question is g of x equals negative 6 over x. Let's see if my copies came out. Make a table. Okay, so are you picking numbers that you will divide picking numbers that negative 6 is the distant one? What's the first number you guys picked? Oh, good, good, that's a good one to pick. There's more copies coming out. I'll pass them out as they become available. What'd you have your ass into? Should be nice, symmetrical branches. And then you were supposed to describe how that compares to 1 over x. So you have to look at the equation. How did 1 over x become negative 6 over x? How did 1 over x become negative 6 over x? You multiply by what? By negative 6. So we're taking a function and we're multiplying by negative 6. So that means we have what kind of transformation? Reflection in the x-axis. Reflect in the x-axis. And then vertical stretch factor of 6. And that's what has happened. It's like switched which sides the branches are on and it's stretched out. Okay, you ready to go on? Flip the page over. And I should have enough copies now. Oh. Alright, does everybody have a copy of these now? Alright, does everybody have a copy now? Okay, we are now on example 2. And example 2, that's translation. You guys can staple afterwards. So what we're going to do is we're going to start with a parent function. And the parent function is going to have that vertical stretch or that reflection, if there is one, just over x. So I'm going to start with negative 4 over x. That's going to be my parent function for my table. So I'm going to start out with my table. And I'm going to pick values for x that I can divide into that -4 easily. What can I pick for x? Goes into -4. -4. -2. 1, 1, 2, 4. And I'll put those in. I'm going to get 1, 2, 4, -4, -2, -1. So that'll be my parent function. And then we have in the denominator with the x a +2. What does that mean? Translate left 2. And then what does this -1 mean? And down 1. So to my x values, I will be subtracting 2. To the y values, I will be subtracting 1. But there are also asymptotes. So when I did my original points, I should have stuck my asymptotes in there right away and I forgot. The asymptotes, remember, are x equals 0, y equals 0. Because those get translated as well. So I'm going to take my x's, subtract 2. Take my y, subtract 1. And I'm going to do the same thing to my asymptotes. X equals 0, subtract 2 is now x equals -2. Y equals 0, subtract 1 is now y equals -1. So we graph x equals -2. X equals -2 is every ordered pair where the x value is -2. If I go find x equals -2 on the x-axis, what kind of line is it going to be? Vertical. And then y equals -1, you go find y on the y-axis, and then you make it horizontal so that every single y value is -1. Those are the asymptotes. Yes, you do need to graph those. Then we plot our blue point. Then you use the asymptotes to help you draw the branches. That's what the asymptotes are drawn for. So you can easily draw those branches. When you're done, look at mine. Make sure yours looks exactly the same. When you do your homework, use your notes. Be back in the parent also. I'm not in the graph. But look how mine keep going past the point. On these ones with translations, I haven't graphed it. Did I have it? Have I graphed it? No. You just have to know the parents you can find. Okay. It does ask for the domain and range. The domain is all real numbers except for the asymptote. And domain is x, so it's all real numbers except what? -2. X does not equal -2. Range is all real numbers except for its asymptote at y equals -1. So y does not equal -1 is the range. Okay, next. So if I'm going to graph y equals 3 over x minus 2, what will be my parent function before any translation? 3 over x, right. So I'm going to pick x's that I can divide. 3. Negative 3, negative 1, 1, 3. So my x's, my y's will be 1, 3, negative 1, negative 3. And then my asymptote, x equals 0, y equals 0. So then what's that minus 2 do? It goes down 2. So translate down 2. So to my y values, I subtract 2. To my y asymptote, I subtract 2. So we graph x equals 0 for the x asymptote, because that one didn't change at all. And then y equals negative 2 would be the y asymptote. We have negative 3, negative 3, negative 1, negative 5, 1, 1, 3, negative 1. And they should look symmetrical, and then you use your asymptotes as guides to help you make those branches. If you're done with that one, set up the table for the next one. Figure out what the parent function is going to be. That's what I'm going to do next. It should be the negative 1 negative. What am I saying? So it's not going to help you whatsoever. It's coming out there. If you don't have the table, if you're not doing the work, you might as well just sit here and watch. You're not going to get anything out of it writing down the graph. Now, if you graph it and you feel like you don't have enough points, you can always add more to the table. Just plug in stuff into an equation. You can always add something. So what's the top? So, no. It'll be negative 1 over x squared. Like this over x. So plus 4 is going to be the translation. Okay? So the next one, we look at the equation and we decide that our parent function is that top number by itself over x. So I have x right here, and I have negative 1 over x as my parent function. So then you can plug in whatever numbers you want for x. So we're probably going to get a lot of fractions. What happens if I put a fraction in? If I put in negative 2, then I'm going to get a half. If I put in negative 1, I'll get positive 1. If I put in negative 1/2, if I have negative 1 and I divide it by negative 1/2, dividing by a fraction is the same thing as doing what? Multiplying by its reciprocal. So I have negative 1 multiplied by negative 2. So that's 2. So if I put in a fraction, I'll get out the reciprocal of it. So I can get more points that way by putting in a half. I'll get out negative 2. By putting in positive 1, I'll get out 1. And putting in positive 2, I'll get out negative half. And remember, the asymptotes are going to start at x equals 0 and y equals 0 before we have any translations. So our translation, it's in the denominator, it's with the x. What's our translation? Translate left 4. So we'll subtract 4. We're translating left 4. Remember, you always do opposite if it's horizontal. So we'll subtract 4 to all these x's. 6, 5, that's negative 4.5, negative 3.5, negative 3, negative 2. And we'll subtract from the asymptote. So x equals negative 4 is my x asymptote. My y asymptote hasn't changed. Y equals 0. And then you grab your points. Negative 6 is half. Negative 5 is 1. Negative 4.5 is 2. Negative 3.5 is negative 2. 3. Negative 1. Negative 2 is negative half. You should have nice little branches in there. Remember, if I get too fast, all of this stuff will be listed. If you are ahead, you're ready to go on, set up the next one. Figure out the parent function. Figure out the translations. Have I pulled my calculator out yet today? No. So when you're doing this, you should be doing this without the calculator. If you pull your calculator, it's totally to check your answer that you've already done. You don't want to hinder yourself for the future when I say, no calculator on this one, and you haven't practiced at all without a calculator. Okay, so number 4, the parent function, before any translation, is what? Before any or adding or subtracting, what's my parent function? 1 over x. And so you can pick whatever x's you want. You can pick negative 2, negative 1, 1, 2, whatever x's you want. You can pick a half. That would work pretty well. And then what does the minus 1 at the bottom tell us to do? I forgot math and x equals 0, y equals 0. What's the minus 1 at the bottom tell us to do? Let's translate right. So we add 1 to our x's. Okay, and then to the y's, what does this plus 5 underneath? Translate up 5, so we add 5 to our x's. So this is where if you pick some, or to our y's, sorry. If you pick better numbers, maybe you have less fractions to do, but if I add 5 with a negative half, that's just 4.5. And then 4, and then 6, and 5.5. And then we have to do the same thing to the asymptotes. I have to add 1 to the x, so we have x equals 1. We have to add 5 to the y, so we have y equals 5. So I'll go put my asymptotes on the graph, and x equals 1, and y equals 5. I haven't finished my graph yet, but I'm just trying to hurry through this. What would the domain be? I know it cannot equal the asymptote. So what would my domain be? does not equal 1. Yep. Because it's going to be everything except for where the asymptote is. And the y's are going to be the same way. So the range, it's going to go negative infinity to positive infinity, except it's going to skip over the asymptote. So what can y not equal? 5. So that would be your domain and range. All right, go ahead and turn the page. Last section. It talks about some. Wait, did I cut this part out for you? Is this part there? Is this part here? Please tell me. Is this example? That's okay. I cut it out, but I couldn't remember which one, so I'm not holding that paper right now. So we're at example 4. All right. So what we're gonna do? You have one. Okay. Are we looking at this one? Are we all looking at this one? No. Oh. Okay, so cross out the 2x plus 1x minus 3 part. Cross that part out. And right above it should be this 3x plus 5. I tried to combine them and then I obviously made a mistake. There we go. Okay, so we should have this. And we're going to change. So they're going to give you, this is not in that transformation form, but we can rewrite it in the transformation form. It's so easy. You guys are going to be like, oh yeah, I know how to do that. Ready? So what does this mean? Division. So we're going to divide those two, and it will automatically change into this form. How do you divide polynomials? What do we do first? What did you do first? I don't remember. You divide, multiply. What do you think on negative 3? Subtract. Okay, so we first look at the term, the x and the 3x, and you think to yourself, okay, if I took 3x and I divided it by 1x, what would I get? 3. So you divide. Then you multiply. So we're going to distribute the 3, and we're going to get 3x plus 3. Divide, multiply, subtract. So we change both of those signs. And we get a 2 for our remainder. Now the good thing is, because these are really short, that's all you have to do. So where we were doing like massive long division before, this looks like a one-step thing. Now, it is in the form that I want it to be in, but I'm just going to have to reorder what I normally do. So what you want to do is you want to write like f of x. I'm just writing in words over here in a second. You're going to write f of x. You're going to put the remainder over the divisor plus the quotient. Whoa, big words. So the remainder up here was 2. The remainder was 2, so we're going to have f of x, or was it g of x? What is it up here? G of x, sorry. It's g of x. Our remainder is 2 over our divisor was x plus 1, and then plus the quotient was 3. You just put your remainder over your divisor plus your quotient, and look, it's in that transformed form. So when you go to make your parent function in the table, what should my y column be? 2 over x, so I'm going to choose numbers like -2, -1, 1, 2. Plug those in, I'm going to get -1, -2, 2, 1, okay. And then what kind of transformations are we doing to the x's? What are we going to do? Oh, I forgot my asymptote. Okay, what am I going to do to my x's? I'm going to subtract 1. So -3, -2, 0, 1. And then what do I do to my y? Add 3. So we have 2, 1, 5, 4. And you guys have a graph to plot it? Let's pull my graph up. Oh, I forgot to write my asymptotes. What's my x asymptote now? X equals -1. And my y asymptote is y equals 3. So x equals -1 is vertical, where x is -1. Y equals 3 is horizontal, where y equals 3. And we just plot the points you guys have. 2, -2, 1, 0, 5. The one that's on the very last page, turn that one and let's go through that one. It's the same, it's just by itself. It's the same time. Let's get an extra one. So that one you're going to use long division to change the form. Try it. Very last page, last example. Use long division to change the form. So you're going to take x and a 2x. How many times? You put your remainder over your divisor plus your quotient. You're not actively participating in this class, you will not remember it. You're not actually doing it yourself. Look it up, there's studies. You're not actually doing it yourself, you will not remember it as well. Question?
Do you multiply 2 and 1?
Oh, I messed up. I mean, I was seeing if I was never paying attention, you know. Good job, David. Yeah, okay. Too bad. Okay, so then this is what I should have, right? I'm just showing you how I am a human and make mistakes as well. I just want you to know it's okay. We all make mistakes. Okay, so from there, if I were to make a table, what would be my parent function? Be 1 over x. And then to my x's, I would subtract 1. And then to my y's, I would add 2. So the assignment is in the book, and you will need 10 graphs. I will pass them out.